Think forward. Think Research Channel.
Hi, I'm Paul Lancaster in University Relations at Virginia Tech, and we are talking today with Joe Loferski, Professor of Wood Science and Forest Products at Virginia Tech. And the topic is decks. A lot of houses have them. A lot of houses have ones that don't meet code, and that's what we're here to talk about today. And Joe, let me start out with a very broad question in terms of what got you interested in deck safety. You've got a lot of interest, and this is one of the top ones.
Yes. Well, I'm interested in engineered wood construction and building performance, especially wood buildings. And in my research, I started to see a pattern in the news, basically, of the fact that decks were collapsing around our country almost every weekend. Someplace in one of the states or one of the cities in our country, there was a deck collapse in which people were being injured. So I started to get interested in this problem and wondering why it was happening, and if there was something that we could do here at Virginia Tech to do some research on it to try to stop this this problem.
And there have been some pretty horrendous deck failures, including some in Blacksburg, right where we are.
That's correct, yeah. For example, one of the most famous unfortunate deck collapses happened in Chicago in 2001, in which 13 people were killed on one deck collapse, and many were injured. But this happens almost in many cities or regions throughout the country, and usually there's multiple injuries, occasionally deaths, unfortunately. And we started to search for this pattern of what was happening and what we can do to stop it.
Well, and you're searching for a pattern. What causes most decks to collapse?
Well, we identified two major problem areas. One was the connection of the deck to the house, and the second was the failure of guardrail systems.
Let's talk about those briefly in terms of the connection to the house. What are they just not up to current code? Were they maybe okay when they were first built as far as meeting code requirements? Are they just old and worn out? What's the deal with that?
Yeah, it turns out that in the building code there really was not much information on how to construct the deck. It was just a couple of sentences in the entire code, perhaps one paragraph on the topic. And it didn't really give builders or building inspectors enough information to determine whether or not the deck was constructed correctly in the first place. But as I mentioned a moment ago, one of the primary problems is that the connection between the deck and the house. And basically what was happening was that not enough bolts or lag screws were being used to connect the ledger board of the deck to the band joist of the house. And in some cases, in addition to not enough fasteners, there was no flashing between the two. So water would get into that connection and it would actually rot the untreated wood of the house. Usually the deck is made from pressure treated wood, so it does not rot, but the house component is usually non-pressure treated wood. So when moisture would infiltrate that connection, decay fungi could get in there and it would actually weaken the connection even further. So that was one of the principal problems that we researched first, was why was the connection between the house and the deck failing. And what we did was we started to do many experiments at the laboratory here at Virginia Tech, and we developed data to answer this problem.
What about the guardrails? What was the big issue there?
With the guardrail collapses, what we found was that the way that the guardrail post was attached to the deck was in many cases insufficient. And often the guardrail is bolted to the ledger or the band joist of the deck. And the way that worked, when a person would lean against the top of the guardrail, their body weight would often be, and the moment arm included in there, because remember the deck post is about 36 inches above the surface of the deck. So it has kind of a crowbar type effect where a little bit of load at the top magnifies to a large load at the base. And what we found there was that many of these connections were just simply insufficient. And we did some research to study that problem also.
And one thing I wanted to mention, because I found this fascinating, was that most deck collapses occur at weights far below what the decks are supposed to be built for. Isn't that the case?
That is correct. One of the things in the building code is it does define the load, the design load for decks which is 40 pounds per square foot, which is the same design load as the first floor of a house. And what we found was, by looking through news articles and so forth of deck collapses, and the news articles would often tell us how many people were on the deck and the square footage of the deck. So we would calculate, we would assume a certain weight per person. I think we were using like 160 or 170 pounds as an average weight. And we would multiply the numbers, and we would find that in many cases these decks were collapsing at half the design load. And there should also be a safety factor on top of the design load. So you should be able to load the deck almost twice the design load and still it would not collapse. Yet what we were finding was the decks were collapsing at half the design load.
Well, you talked about decks and that sort of thing, and we actually went out with you on an inspection, so I'd like to take a quick look at that and give people at home an idea of what went on with that inspection. So let's take a look.
So we're at an existing deck, and the question is this deck safely constructed, or do we have some problems that the homeowner should be concerned about? Well, what I look at when I walk up to a deck to inspect it, the first thing I'm always worried about is how is the deck connected to the house. So in this particular instance, we see that we have an overhang from the house wall to the deck. So this always to me is a bit of a concern, because the way that the deck is attached to the house is through this ledger board, which I'm pointing to with my tape measure up here. We see that we have the ledger board is attached with nails at this location. We can see 3 nails, and we see a couple of bolts. For example, there's one bolt here. The head of the bolt can be seen, and then I look all the way over to here before I can find the next bolt. And so I measure that, and I can see that it's approximately 48 inches between these two bolts. In the research that we've done at the laboratory at the university, we found that really for a span of, for decks which are spanning about 10 feet, such as this deck, these bolts should be spaced approximately 16 inches on center. And instead we have bolts spaced 48 inches on center. I assume that these nails are ineffective. In our research at the laboratory, we found that just holding the deck to the house with nails alone is simply not sufficient, and this has caused many deck failures in the field. So homeowners who can find no bolts or insufficient bolts or lag screws such as this, these by the way could be lag screws, really should look into reattaching this deck with some more fasteners. So another thing I look at when I'm inspecting a deck is how are the joists connected to the ledger board. In this particular deck, we see that we have a 2x4 that is supporting a notch in each of these joists. And this may work, however, we see that the 2x4 is only nailed in to the ledger board. So a better way to do this would be to have joist hangers which are attaching the joist directly to the ledger board. Other things that I look for on a deck such as this is how is the ledger board attached to the house, and is it correctly flashed? Flashing, of course, is a non-corrosive metal which is designed to direct water away from that joint. Typically, the ledger board of a deck is made of pressure-treated wood, so it will not decay. However, the house components that the ledger board is attached to is typically made from non-pressure-treated wood. So if the flashing is not sufficient and moisture can get in between that interface, the house components can start to decay, and then whatever the bolts are or lag screws which are attached between the such as this bolt here, which is attaching the ledger board into the house, it may actually be in rotted wood in the house component. So this is something else which needs to be inspected, is how is that flashing condition, and that would be best done from above the deck or on the deck surface. Okay, another thing which I look for when I'm inspecting a deck, and a homeowner can also look for in their own deck, is how are the girders attached to the post. And in this case we can see we have 2 bolts which are attaching that girder to the post, but also there is a notch which is, the post itself is notched, which is so it has a let-in area so that the girder is actually bearing in a wood-to-wood context, and that's very strong connection. So I think that on this deck that is not much of a problem, not any problem. Another thing which I always look for is how are the joists attached to the girder. So in this case I can see that we've got, in some cases, for example here, a toenail which is nailed through the girder and into the joist, but I do not see fasteners on the other joists. So this is a situation that a homeowner may want to come and reinforce that connection, perhaps using a metal clip, which I will show you later, or which can be attached between the joist and the girder element itself. Another part of the deck which a homeowner should inspect, because it is critical to the safety of the deck, is the guardrail system. So if we look at this guardrail on this house deck, we see that we have pickets which are nailed to the bottom rail and the top rail. The connection of that picket to the rail must be strong enough to keep people from falling through. We can see we have 3 nails holding this in. Screws might be better. Another thing to look for is the spacing between the pickets. The spacing should be no more than 4 inches. And also the spacing between the bottom of the rail and the top surface of the deck should also be no more than 4 inches. And this is designed to keep children from falling through for safety purposes. Another thing to look for in the deck is the type of post which is holding the whole guardrail up, and which is attaching the guardrail system into the deck. In this case, we can see that we have 3 bolts, and all 3 of these appear to be corroded. I'm not sure this would be a sufficient connection. There are better ways to do it. This particular post is 2 inches by 6 inch, so it's a 2 by 6 inch guardrail post. And a much better way is to use a 4x4, which is rigidly bolted to the band joist of the deck, and to use a particular type of fastener which then connects the band joist of the deck to the joists of the house, again through bolts. And in the laboratory we have tested these types of connections and found that the connector that I will show you in a later segment, is really the strongest and best way to connect guardrail posts to decks. We found that when we test these types of systems, which we do in the laboratory, we have yet to find one of these which actually can meet the building code requirements for the load carrying capacity of a guardrail system. And I think that's it for this deck. Those are the major things that I like to look for.
And that's a pretty scary look at a deck that was built probably in the 80s, and that's a situation with a lot of these 80s decks. They were very popular back then with the split levels and all that sort of thing, and there's probably a lot of decks out there that are in that kind of shape.
That's correct, yes.
What can we do about that? People tend not to worry about that sort of thing unless they're selling the house and there's an inspection of the whole house. What Can homeowners kind of get their own idea of what's going on? Are there some things they can look at for sure to find out if there's problems?
Yes. Well, each deck is unique. There's no set standard for how decks were constructed. And what homeowners can look for immediately is if they have access to underneath the deck, they can look and see how many fasteners, how many bolts or lag screws are used to attach the ledger board to the house, and what the spacing of those lag screws are. In our research, we have published design tables for people to use that they can actually measure the span of the joists, and we tell them how many inches apart the lag screws or the bolts should be that are attaching the deck to the house. So that's the first thing that a person can look for.
In the case we saw, they were a lot further apart than current standards.
That's correct, yes. For example, on a 10-foot wide joist span, the lag bolts should be spaced, or the bolts should be spaced approximately 16 to 18 inches apart. I don't remember exactly because I don't have the table in front of me, but it's in that size. Another thing a homeowner could look for is to determine if there's only nails which are holding the ledger board to the house. And we've identified that this is a major problem, that many deck collapses were held up only with nails. And that might be good for a short-term loading situation, but when the decks age due to moisture and so forth and they're exposed to the weather, the nail joints are simply insufficient to carry the kind of loads that we're talking about for design loads.
And without any flashing, nails are really bad, and even the bolts would give way at some point if there's enough rotting of the wood in the house that's not been treated.
That's correct, yeah. So they could look for flashing details and things like that. Another thing a homeowner could look for in their own deck is the guardrail system. And at the very minimum, the guardrail pickets should be spaced no more than 4 inches apart. The building code currently says that a sphere 4 inches in diameter shall not pass between the pickets.
And that's based on kids getting stuck and that sort of thing, or actually falling through, sort of deal.
Yes, exactly, right. We don't want children to have to be able to push their body through and fall to the ground below. So that's one thing that a homeowner could look for. Another thing that they could look at is how is the post connected to the deck? What does the connection look like? Is the post split? Are the connectors corroded? The bolts or whatever it is that's holding that up? Is the post notched? That's another thing that we found on many, many decks, is that the carpenters notch the bottom of the post so it sits on, it sits on the deck in this notch. And in our research, we find that a notched post reduces the strength of that post significantly. In fact, it reduces it so much that it's almost 1/3 under-designed for the design loads.
It seems to me the idea there would be to have part of the post resting on the thing, theoretically making it safer, resting on the deck. But it turns out that it's exactly the opposite.
Exactly.
I guess this is more splitting because of that notch that's been made.
That's correct. The notches actually create a stress concentration in that corner of the notch, and the split can occur from that point where the notch is, and it can really reduce the strength of the post.
How can that be remediated? You have to start from scratch, I would think.
Yeah, for that part, perhaps the guardrail would be rebuilt if the homeowner determined that they had these types of posts and they could see the splits already. They know that this is not going to be a sufficient guardrail system, and recognize that when they're having a party or their friends are over, these are usually happy events. Maybe they're having a reception at their house, and one of the last things you want is to have that guardrail fail when people are leaning against it and have them drop 8 to 10 feet from even a 4-foot fall can be catastrophic to in injuries.
Well, I would imagine that a homeowner may take a look and see that there might be some problems, but there might be the idea of going out and getting somebody to come in and inspect. While that's a good idea, I suppose the idea of who's doing the inspection may turn out to be a problem too. Are there certified deck inspectors out there?
Well, right now there really are not certified deck inspectors. There are home inspectors who may be able to do this, but one of the things that they really have to know about is some of this research that has been done here at Virginia Tech, and to examine these critical connections. What I've found in the past is many inspectors simply come out and measure the size of the joists and the span of the joists, and they compare it to a span table, and they say, yes, this is correctly done. Well, that might be true for the joists, but what we find is it's not the joists which fail in these deck collapses, it's the connections between the house to the deck or the guardrail system. So somebody who knows about these types of things is the person that should be found to inspect the deck. We wrote a book on this topic called The Inspection Manual for Decks and Balconies, and this book was written by one of our graduate students and my research colleague, Professor Frank Wieste, who now is a retired professor, but he's a professor emeritus. So he still works at Virginia Tech and with Virginia Tech, trying to get the word out about this type of a topic. So a person could purchase this book and get it to the person who's actually going to inspect the deck. In other words, the homeowner could buy this book, give it to the deck inspector, and make sure that inspector knows what they're looking for.
Well, and let me mention now that we will have at the end of the program some information about where to get the book, perhaps, and some other sites to go to as far as getting decks inspected, that sort of thing. So I want to make sure people could follow up on this. I wanted to ask about, and this is kind of a ballpark question in terms of, I would imagine that the vast majority of the decks built in the 80s don't meet today's code.
I would agree with that statement. In fact, we have inspected many decks for our research, and we have yet to find a deck that meets the building code.
That's not very good news.
It's not. Recently, some of our research data was adopted by the building code, and some of the tables for the span tables for our research, the deck ledger connections, have been published in the International Code Council building codes. So this has been a real boon, I think, for improving the safety of decks. Also, the American Wood Council recently published a new document called, it's DCA 6, and this stands for Design for Code Acceptance Publication Number 6. And in it, it has construction details for new decks. So hopefully, as we move forward in the future, building inspectors will have access to this document, and so will builders, so that decks can be built to code from here on out.
If somebody gets a deck on their house built now, is it required that a building inspector come out and take a look at it?
In most states which have building codes, this is required. Some states do not have building codes, statewide building codes, but they often do in certain towns or cities even within those states. In Virginia, we do have a statewide building code, and any structure which is built in the state should be inspected and must meet the codes.
Well, this gets into a question I wanted to talk about in terms of, you've got research going on, and we hear a lot about research going on for years and years, but this is something that is going directly from the lab to the public in terms of safety. Talk about that a little bit, how you influence the code for deck building.
Yes. In our research, we felt this was such an important and practical problem, and we wanted to get the research results into the hands of the users, the people who actually build decks or who use decks, and who inspect decks, the building officials who actually come out and inspect. So we decided early on in our research to publish our results in magazines and journals which builders read and which building officials read. So we published, for example, in the Journal of Light Construction. I think they have 100,000 subscribers who are mostly builders. We also published in another magazine called Building Standards, and this is subscribed to by most building official offices across the United States. So this has been an avenue that we've been able to get this information out. In addition to that, we teach short courses, 1 to 2 day short courses around the region of the eastern United States, even in the western United States. We've taught these courses, and we've so we hold these 2 day events. We attract building officials, builders, engineers, and architects to these workshops, and we discuss these details of how decks should be constructed.
I want to talk about, we've talked about connections to the house, but there are also freestanding decks. Are there certain problems there that have been neglected in the past?
Well, the freestanding deck is, I think, the best way to build a deck today.
Okay.
And it can be connected to the house the way that the non-freestanding deck is, but also, in addition to that, it has another set of columns and a girder which is located near the house foundation. So instead of having the beams, the joists attached directly to the house and only with that connection to carry all the load, there's a second set of load carrying members. And this is another set of columns and another girder which is located at the house, or adjacent to the house, perhaps 6 inches to 1 foot away from the house. And in our research, we have not, knock on wood, we have not found any evidence of a column failing or the girders failing to cause a deck collapse. So our feeling is that if we have the second set of girders located next to the house, this will really improve the safety of decks.
In other words, the standard of connecting to the house is merely a reinforcement to what should be the primary method of keeping everything safe.
Exactly. And in fact, in that type of a construction, the deck to house connection would really maybe resist the lateral loads, so the shifting of the deck laterally rather than carrying gravity loads only.
Let me kind of start wrapping up in terms of asking about current research. What kinds of things are you looking at these days as far as decks are concerned? What's the latest trend that you're investigating? Well,
we've been studying the guardrail problem and the post-to-deck connection. And we've developed several designs using commercial connectors, which, when they're applied to the deck, they increase the strength of that connection radically. In fact, in our testing machines, we have yet to break one of these connections, even at 2.5 times the design load. So we're trying to get this idea into the building code so that people can have guardrail systems that will not fail. So we're developing new connectors for that particular purpose. Another thing we've been looking at recently is the handrail system on steps. So where decks have steps that go to the ground, the handrail should also be strong enough to carry loads. In case somebody trips or falls, they have to lean against the handrail. And we're looking at how those handrails are connected and what kind of loads they can carry.
So a lot of stuff going on and a lot of stuff already in existence that homeowners probably need to take a look at. We've been talking with Joe Loferski, who's professor of wood science and forest products here at Virginia Tech. Take a look at your deck. I'm Paul Lancaster of University Relations here. Thanks for joining us.
Think forward. Think Research Channel.